All right, 4b, 4b. We are solving quadratic equations. Remember, when you solve a quadratic equation, you find the solutions to the equation when it's equal to 0, and we call those solutions roots or zeros. They mean the exact same thing. And they manifest themselves on the graph by crossing the x-axis or the x-intercepts. Okay, so step one. What do we do step one if we're trying to solve this equation? Get it equal to 0. So I'm going to bring the 8x across, and I'm going to write it in descending order. So that's going to be a minus 8x in the middle, and then minus 5. Yes, yes? Yeah, this is 4b. 4b. All right, so you write it in standard form, which is descending order degree, x squared minus 8x minus 5. Now, if you were just left to your own devices here, you would try to factor it. Are there factors of negative 5, though, that add up to negative 8? 5 is prime, and it's only a 5 and 1, right? 5 and 1 is 6. It's not 8. So it doesn't factor. Hey, good thing we have what still that we can use? The quadratic formula. So let's go ahead and write down our a, b, and c off to the side. The leading coefficient is 1. I'll put it there. That's a equals 1, b equals negative 8, and c equals negative 5. I like to write them out. I like to see them. So I write them off to the side. Now I'm going to put x equals, and I'm going to write the actual formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And of course, what is the name of b squared minus 4ac? What do we call it? The discriminant. Very good. Because it allows us to discriminate which types of solutions we have. If it's negative, then we have an imaginary solution, no reals. If it's 0, then there's only one solution. And if it's a positive number, then it's plus or minus a positive number. There's two solutions. Okay, let's go ahead and plug in carefully, though, first. We get x equals the opposite of b. What's the opposite of negative 8? Positive 8 plus or minus the square root of. What is b squared? What is negative 8 quantity squared? Positive 64. Yeah, you should always get a positive number there. A negative number squared is positive. Minus 4 times a, which is 1, times c, which is negative 5, all over 2 times a, which is 2 times 1. All right, let's simplify. We'll just keep working straight down now. Let's do the discriminant off to the side, just in case, okay? Here's the discriminant off to the side. Disk, we'll call it disk. We get 64, and then that ends up being plus 20, right? So that's the square root of 84. Now, because it's a positive number, how many solutions are we going to have? 2. 2 solutions, because it's going to be plus a positive number and minus a positive number. Those are 2 distinct solutions. Is 84 a perfect square? No. So now we have to do our factor tree. What are 2 factors of 84? Any 2. 2 and 42, because it's even. I know there's a factor 2. 42 is also even, so how about 2 and 21? And now 21 is not even, but I know 3 goes into it, and it's 3 times 7, both of which are prime. So it's 2 times 2 times 3 times 7. How many factors does it take on the inside to become 1 on the outside? 2. Do I have a pair of 2s? I sure do. So I can pull one of those out front, and then these 2 guys that don't have matching partners can pair up with each other and get 21. Now, speaking of pairing up, tomorrow is twin day. I forgot it was Jersey Day. Tomorrow's twin day, so I might dress up as... I might twin with someone. I'm going to see if Coach Fair wants to twin with me. Coach Fair, will you twin with me? If not, I'll ask Coach Kilford. Coach Kilford, will you twin with me? They're going to say no. And then I'll ask Coach Pfeiffer. Coach Pfeiffer, will you twin with me? And he'll say no. So then I'll ask Principal Hughes. We'll see how that goes. Okay, so it's 2 times the square root of 21. I'm going to bring that back into my answer over here. So it's 2 square root of 21 all over 2. So it's definitely worth going off to the side and doing the work with your discriminant because it's a lot of work. All right, now the fun part, right? The part that people are still kind of getting confused over. We got to split it up. So it's plus or minus 8 over 2, sorry, plus or minus 2 square root of 21 over 2. And then we simplify if we can. Oh, I think we can. 8 divided by 2 is what? 4. And what happens with these 2's? They divide out. Remember, things cancel to give you 0. They divide out, so we just get the square root of 21. And there's your conjugate pair. Conjugate pair of solutions. Yeah. They're not complex, are they? They're not imaginary. They're real. They're irrational. The square root of 21 is what we call an irrational number. Conjugate pair of, I'm going to add that to here, irrational solutions. Radicals that don't simplify are irrational. They're non-terminating, non-repeating decimals. All right. So we've worked two quadratic formulas, right? We know how to do them. It's a little tedious, but hey, when you got a workbench over here and you got all the space to do all your stuff on the side so that your project, notice my project is working straight down here and there's no interruptions to it. Every line is equivalent to the one above and below. Yes, yes? You're starting to work like that. You're starting to improve the way you work, not just getting the right answer. You're communicating your results. Okay, so we've gone through several different methods here for solving. Let's kind of review them before we get to the last one. The first one was graphically. That was with the calculator. That was kind of the no fun method because the calculator takes all the fun out of it. But we set it equal to 0. We graph it, and then we graph 0 and y2, remember, and then we second trace number 5 it. If there was no x term, if there was just an x squared and a number, we separated the x squared from the numbers and we extracted the plus or minus square root. If it factored, which is what we always try to do when we set it equal to 0, we try to factor it. If it does, we can set each factor equal to 0 using the zero product property. And then we just saw using the quadratic formula. Once we get it equal to 0 and we see that it doesn't factor, we can identify A, B, and C, and we can plug it in, work it out. All right, the last way to do it is by completing the square. And you already know how to do this. We've already practiced completing the square. Yay! All right, let's try it out. Example 5. Find the zeros of the function by completing the square. Check your answers graphically. Okay, so step 1. I got an x squared term and an x term and a constant. If there were no x term, let's say there were no x term here, I would bring the 40 across, I'd divide by 2 and take the square root of both sides. But because I have one of each, I have a squared term, a non-squared term, and a constant, our goal is to get everything on one side and set it equal to 0. So 12, you come across, now you're negative. I'm going to put you in the middle because that's where you go in descending order, and now it's equal to 0. All right, so far so good? All right. I need to complete the square. What's the first rule of factoring, actually? To pull out a common factor. Is there a common factor here? There is a common factor here. So the way I would teach you is to pull the 2 out all the way across, even with the 40. So you're going to get x squared minus 6x plus 20 equals 0. Now, you would try to factor what's left on its own. Are there factors of 20 that add up to 6 or subtract to give you 6? 1 and 20, 2 and 10, 4 and 5. None of those add or subtract to give you 6. So it doesn't work. So here's what's kind of nice. Because it's equal to 0, we don't have to worry about the 2 anymore. In fact, you could actually divide both sides by 2 if you want. Okay, let's just get rid of it because it's going to complicate what we're doing. All right, we divided both sides by 2. What's 0 divided by 2? 0, okay? Now we can try to complete the square. The leading coefficient is already a 1, isn't it? Because we factored out the 2. So we get 1x squared minus 6x plus blank plus 20 equals 0. Remember doing that? If the leading coefficient is a 1, you don't have to complete the square inside the parentheses. You just add a clever form of 0. All right, now remember how to do that? We take the middle term and we do half then square. Half then square. What's half of negative 6? Negative 3. And what's negative 3 quantity squared? Positive 9. You're always going to be adding a positive number. And since there was nothing factored out, we just need to put a negative 9 right there. And now we're ready to go. The first 3, if we associate them together, we double bubble it squared. And that becomes x minus 3. If you recall doing that, the square root, the middle sign, squared, and then 20 minus 9 is plus 11, and that equals 0. Now, if we were interested in where the vertex was, it would be at 311. But we're not interested in the vertex. We're interested in solving. So we're going to tap into a skill that we learned up here. Come back up here. When it said to solve by taking the square root. When you just have a squared term and a constant, you are going to solve by separating. You're not going to set it equal to 0 anymore. You're going to separate or isolate, as it says up here. Okay, that's what we're going to do. We have an x squared term now, but it's a quantity. So that's the next thing we want to do. We want to isolate the square factor. Okay, so I'm going to get x minus 3 squared equals negative 11. Ugh. Now, how do I undo squaring something? What's the opposite of squaring something? Square rooting it. Yeah. So I'm going to take the square root of both sides. Okay, I'll put that here. We'll square root both sides. I'm trying to get at the x, so I'm peeling back the layers here. So now I take the square root of both sides, and I get x minus 3 equals plus or minus the square root of negative 11. Plus or minus the square root of negative 11. Now, before I proceed, I'm going to notice that I just took the square root of a negative number. Are these going to be real solutions? No. They're going to be imaginary solutions. Imaginary solutions. So what I'm going to do before I proceed then is I'm just going to get rid of the negative under the radical and put an I outside the radical. Everyone's going to do that every time you see a negative under a square root. You're just going to bring that negative outside and call it I. Oops, and where did my equal sign go? They're right there still, equals. And now I just add 3 to both sides. I add 3 to both sides, and I get 3 plus or minus the square root of 11 times I. And guess what? Those are your two solutions. These are your two complex conjugate solutions. 3 plus the square root of 11i and 3 minus the square root of 11i. And we put the number first, right? A plus bi format. So let's review what we did there. We factored out the 2 all the way across, and then I divided through to get rid of it. Because it was equal to 0, I could just get rid of it. And then I completed the square, half then squared, opposite, squared it, and then I isolated the square piece, took the square root of both sides, and then solved for x. All right, let's try the next one. I'll get you to a certain point, then I'm going to let you finish it on your own. If I'm trying to find the zeros of g of x, what should be the first thing I do now, since it's not an equation that I need to solve, it's just a function that I'm talking about? What must I do first if I'm interested in the zeros? Is there really an equation to solve yet? I got to set it equal to 0, yeah. Because it's a function that's given a name, I got to set it equal to 0. All right, now I want to factor it. What's the leading coefficient? Negative 1, yeah. So because it's equal to 0, here's what you could do. You can multiply everything through by a negative. That's legal. Once it's equal to 0, multiply both sides by negative 1. What that's going to do is change the signs of every term on both sides. That becomes positive x squared plus 14x minus 23. And what's 0 times negative 1? Still 0. It doesn't change that side. You can only do that once it's equal to 0, because notice that changes the function. The original function opens down. I've made it open up. Okay, so what's essentially happening here is we have a parabola that opens down, and here's one x-intercept and here's the other. I just multiplied through by negative 1 and made it open up. But guess what? It's going to have the same x-intercepts. Okay? The reason I want to do that, remember, is because I want my leading coefficient to be a 1, don't we? So now if I complete the square, that's x squared plus 14x plus something minus 23 equals 0. And because my leading coefficient is 1, I don't need to complete the square inside the parentheses. I just half then square. What's half of 14? 7. 7 squared is 49, and this has to be a negative 49. So from there, y'all finish. Factor it, combine it, and then solve for x like we did over here. Okay, I'm going to work it quietly up here and see if we get a similar answer. On your mark, get set, go. when you're done, or if you get stuck. Take a look up here and see if you got it. Oh yeah, but that we don't remember when we complete the square. We don't just add 0 and then combine them. We group it like this. Okay, and that's how that becomes this. So that 49 is already taken into consideration. This is what's left over. Right. Yeah. Yeah. Oh, we can. Yeah. Yeah. I'm sorry. I didn't simplify that all the way. You're right. 2 times 2. There's another 2. So the square root of 72 actually. Yeah. Very good. Excellent. Yeah. Very good. I didn't factor the 4 all the way. Now you can match it up with mine. Maybe yours was more correct than mine to begin with. 72 is 36 times 2. 36 is the largest perfect square factor, but it's 9 and 4, which both got. So again, when we complete the square, x plus 7 squared, and then we combine what's left over to get negative 72. Now that I have a squared term, I separate it, take the square root plus or minus square root of 72. That's where I go off to the side and finally do my correct work. Bring the 6 square root of 2 back in, and then it's just a matter of bringing the 7 across and putting it as negative 7 in the front. And there's what we call your irrational conjugate pair. It's not imaginary, but it's still a conjugate pair. Negative 7 plus or minus 6 square root of 2. Okay? Boom, you're done. Okay? Completing the square and then taking the square root of both sides. That concludes the notes. It's a pretty big section. There's a lot of techniques in here. Solving quadratics is a very, very, very important thing. Yeah, and I'm not gonna check it on the calculator, but if you checked it on the calculator, you would get these two solutions right here. You would get the decimal versions. Okay, the decimal versions you would have to verify by typing these in and seeing what the decimal values of those are. I'm not going to bother with that. We know we're right. Okay. All right. Any comments or questions on this section? 5.2, solving quadratics. I'm going to give you your quizzes back to you now to take a look at. And if you have any questions, we can go over those as well. If not, you have the rest of the period to work on 5.2.